Hi everyone, in this video we are gonna talk about simple linear regression. I know this topic may be somewhat difficult for you to figure out. I will try my best to give you kind of intuitive understanding or intuitive explanations or intuitive descriptions about regression analysis. I'm not going in depth about formulas in the textbook to calculate some statistics, related statistics, because I know you'd better use SPSS or another statistics software for this kind of advanced statistical method that requires kind of sophisticated, complicated, or complex calculations. There are some assumptions we need to take care of in a regression analysis, and it is difficult to test the assumptions by manual calculations. Okay, my lecture will focus on some basic concepts in relation with linear regression, kind of sort of logics or principles of regression, and some critical issues to be addressed in order to use a linear regression analysis without any mistakes. I will show you kind of A to Z procedures for a regression analysis using SPSS and how to interpret the SPSS output. Okay, so do not be intimidated by the complicated calculations and descriptions about linear regression in chapter 18 of our textbook. As far as you understand the materials in this video lecture, you will be just fine. Okay? A simple linear regression involves a single independent or predictor variables and a single dependent or outcome variables. It's basically based on the significant correlation of the independent and dependent variables. Okay. The difference between a correlation analysis and a simple regression analysis is that while the correlation does not distinguish between independent and dependent variables, in a regression analysis there is always a designated predictor variable and a designated dependent variables. This is because the purpose of regression analysis is to make predictions about the value of the dependent variable given certain values of the predictor variable. Okay. The benefits, one of the benefits of conducting a regression analysis rather than a correlation analysis is the regression analysis generates more information, and the regression equation allows us to think about the relation between the two variables of interest in a more intuitive way. What I'm saying is that, while the correlation coefficient provides us with a single number, the correlation coefficient is just single number, right? Let me show you. To recall your memory, correlation coefficient, just a single number like this, okay? It's single number like this. Point minus 0.971 here, okay? 0.826, 0.826. That's single number. The correlation coefficient is single number. But the regression analysis enables us to generate a formula like this, formula for calculating the predicted value of one variable when we know the actual value of the second variable. Okay. Basically it's about regression analysis is to predict values of dependent variable of our interest. A commonly used analysis method for a simple linear regression is ordinary least square. Here. I will show you how this works for accurate predictions. Okay. Sometimes we need to use weighted least squares if the data does not satisfy the assumption of homoscedasticity. A simple linear regression equation looks like this. Y hat equals a plus bx. Okay, y hat is predicted value of dependent variable. X here is actual x value. We are gonna input to calculate, predicted value of y or independent variable. Y hat is not actual value of dependent variable. This is predicted, expected value of dependent variable. Anyway, regression equation looks like this. The regression equation, which is y hat equals a plus bx here again, it represents a regression line that minimizes prediction errors. This is a key point, one of the key points you need to know about a simple linear regression or any regression analysis. Okay, this equation represents a regression line that minimizes prediction errors. That's basically how this ordinary list square method, estimation method works. Okay, I'm gonna show you why through an example soon. Before getting into an illustration, here are some critical assumptions of simple linear regression. The first assumption is about linearity. If the correlation is curvilinear, we learned about this. The correlation can be non-linear or curvilinear. Then we have to make it linear because of this assumption of linearity. Okay, linearity. If this assumption, linearity, is not met, we have to try to make the relationship between variables linear through data manipulation, which is beyond the scope of this class. We are not going to do this in this class. Like I said, you will have a chance to handle this kind of data manipulation when you if you have chance to take an advanced statistics class. The second assumption here is normality of errors. And the third assumption here, homoscedasticity. Just remember we have this kind of assumptions to satisfy for an accurate linear regression analysis. Okay. The last one here, independence of observations, is basically about random sampling. Okay. If we are handling sample data, we are mostly we are handling sample data, so we have to make sure our data is from random sampling. Random sampling is basically about data collection. So there is nothing we can do at this moment of data analysis. This is a topic of data gathering. So just don't forget that it is very important to design random sampling to make your data represent the population as much as possible in order to minimize the estimation errors. Okay. Now let's talk a little bit more about regression equation. About this. Basically, what we do with regression, I mean, what we are supposed to do in regression analysis is to identify A and B that can be used to predict a certain value of a dependent variable, which is y hat here. Okay, given a certain value of independent variable, which is x here. Okay, so what we are gonna do now is to do a regression analysis with SPSS to get each of these components, I mean A and B. In this equation, and then interpret the equation that represents the relationship between independent variable and dependent variable. A here is intercept, I mean the point where the regression line intercepts the y-axis. Okay, if you have regression line like this, intercept A is, right here. Okay, the point where this regression line intercepts y-axis. Okay, here, this point. This is A, right here. The component of this regression equation. Meanwhile, B here, which is regression coefficient, is the slope of the regression line. Please recall your memory from middle school or high school about the slope. It's basically delta x. I mean delta y over delta x. Delta y divided by delta x. That's the slope over this line. Okay. On the SPSS output, I'm gonna show you where it is on the output. of your regression analysis. Okay. Now let's talk about how to get a regression equation through an example using SPSS. I'm going to use the first example of correlation analysis. I mean this data again here. Let's suppose that specifically we want to investigate how educational level would influence income level, monthly income. Educational level is measured in years. How many years of education? Say beginning with kindergarten and extending through graduate school. Income data is measured the amount of income, monthly income in $1,000. It's monthly income in $1,000. Suppose that, just simply suppose that we randomly selected a sample of 10 adults and measure their level of education like this and their monthly income like this. Now we are going to do a regression analysis using this data set. The purpose of a regression analysis again is to identify intercept and the slope or regression coefficient of the regression equation. What I'm going to show you now is basically where the information about this intercept and the slope or regression coefficient is located in the SPSS output of regression analysis. Okay. Please refer to the SPSS instructions, the PDF file, as we do this sample analysis. It's from page 32 to 34. Step 10, from step 10 here to step 13. Okay. Let's go to the SPSS data view window here. we already got the data, raw data from this Excel spreadsheet to this SPSS data view window. Click Analyze button here. Select Regression here, and we are doing linear regression. right? So just select and click this linear option here. Again, analyze, regression, and linear. Click linear option. Which one is dependent variable and which one is independent variable? Education or income? Our research interest was, to see if education level influences income level. So income level goes into this dependent variable box, and educational level goes into this independent variable box. Okay. Now click this save button here. We are going to generate a new variable or data that we are going to use for testing the assumptions, the assumption of linear regression. Just click this save button and click this, mark this unstandardized in this residual box. Okay, just mark, click this unstandardized, add, continue, click continue button at the bottom of this save pop-up window. Then click OK. Okay, at the bottom of the linear regression pop-up window. Click OK. Then we get this output of regression, the result of our regression analysis. Okay, here is a table of model summary. We are going to use this, and the ANOVA table here, we have p-value here. And coefficient table. We are gonna use all these tables, all these three tables for our linear regression analysis. Okay. From this model summary table, we are going to use this R square here. R square. From this ANOVA table, we are going to use this p-value. Okay. And from this coefficient table, we are going to use this unstandardized coefficient B. Okay, B. The first one is constant. And the second one is education. Okay, this is minus 3.7708. This is A that we are looking for in order to establish our regression equation. This is A. Do you remember? Y hat equals A plus B x, right? A is located right here. This is the constant in the table of coefficients. The point 0.605 is the slope of this regression equation. Okay, just copy this coefficient table, copy, and go to Excel worksheet or Excel spreadsheet. Just paste, right click and paste. Here, like I said, this is, let me put one more time, y hat, which is A plus bx. Okay. This is A in the SPSS output table. Is coefficient table to be specific. The unstandardized coefficient B. The first row constant minus 3.708. This is A. Unstandardized coefficient B. The second row, education, which is independent variable in this regression analysis. Independent variable x, the coefficient of x, am I right? Which is 0.605. That's the slope of the regression line. That's B. So see, I'm gonna get the regression equation here. Y hat, let me put here, y hat equals A. A is minus 3.708, right? A plus because the coefficient, regression coefficient B is plus, positive value, right? There, so plus 0.605. 605 times x, or just x, okay, or times x, right? This is the regression equation. There is one more information we need to get from this SPSS output. The model summary table to be specific. Here you see the R square here, R square, that which is 0.683. Just get this R square from this model summary table, around here, R square here, R square from this table, model summary table, R square .683, right? That's another information we need to get from the SPSS output of our regression analysis. Okay, I'm going to show you how to interpret this R square, or coefficient of determination. Now we are ready to interpret these results. I mean the regression equation and R square, or coefficient of determination. Okay. Before interpreting the result, we need to make sure the coefficient, regression coefficient B, which is 0.0605, is statistically significant. If this coefficient is not statistically significant, there's nothing we can get from this regression equation. So where is the p-value for this regression coefficient? Here, 0.003. Do you remember this 0.003? Back to this, the first correlation analysis. The p-value for this correlation coefficient was 0.003. That was our first correlation analysis with the same data, education level and monthly income level. We are using the same data for this regression analysis. The p-value for this regression coefficient, the same 0.003, which is statistically significant. So the regression coefficient, which is 6.605, is statistically significant. We can safely use this coefficient in predicting what the dependent variables. I mean, we can use we can safely use this equation, regression equation, because the regression coefficient is statistically significant. Okay, if this regression coefficient, which is 0.605, is not statistically significant, we better discard this SPSS output. Don't use this SPSS output. Okay. Anyway, the correlation, the regression coefficient is statistically significant, so we can safely use this information of regression coefficient B, the slope of the regression line, right? So here is how we can interpret the result. The first interpretation, or the first conclusion is education level significantly influence income level, right? Because of this statistically significant regression coefficient tells us that education level significantly influences income level. Okay. The second conclusion, second interpretation we can make from this information. The R square here, R square 0.683, which is 83.3%, means that educational level, this independent variable educational level, explains approximately 68% of variance of income level. The third interpretation, which is about this correlation, regression coefficient, which is 0.605. We can interpret that like this. For every additional year of education, right? For every additional year of education, we would predict an increase of 0.605 or $0.605 thousand dollar, or by multiplying 0.605 by $1,000 becomes $605, right? Okay. Again, for every additional year of education, we would predict an increase of $605 in monthly income. That's how we interpret this regression coefficient. Where is this $1,000 coming from? Here. The income level was measured in $1,000. Amount of monthly income in $1,000. So we have to multiply $1,000 to get the predicted value of dependent variable. Alright, in this video we talked a little bit about simple linear regression. I focused on how to get a regression equation, I mean the intercept and regression coefficient from the SPSS output of a regression analysis, and then how to interpret the regression equation, especially about regression coefficient.